Algebra 1, here are your notes for 10.2, solving by graphing and factoring. So we looked in our last lesson at how to graph one of these. So let's just do a quick review of that. Remember that the first thing we're going to start off by doing is creating a table over here, a table of x's and y's that will help us graph our final quadratic. Once we have our table, we're going to start by finding the vertex. Hold on, let me adjust my camera a little bit here. There we go, that helps. So remember that the vertex formula is always going to be negative b over 2a, where b and a are the coefficients of x squared and of x. So in this case, when I have my vertex, it's going to be negative 6 over 2 times the number out front of my x squared. That would be a 1. When I solve this, I get negative 6 over 2 or negative 3. This is my vertex. It is where my parabola is symmetrical. And I know that it's going to be symmetrical because I know I'm going to have 2 points on either side. So I'm going to do negative 4, negative 5, and negative 2, negative 1. I'm going to go to negative 3, of course. And as I said in my last video, I like to mark my axis of symmetry just so I know where I'm supposed to be looking. From here, all I'm doing is plugging my x's in and finding out what my y is. So when I plug in negative 3, I'm going to get negative 3 squared, which is positive 9. When I plug it in here, I get negative 18. So positive 9 minus 18 is negative 9, plus 8 is going to be negative 1. And if you need to show your work for that, go ahead and feel free. I'm just not going to for the lack of space. Once I have my vertex, then I'm going to go and plot it. So negative 3, negative 1. There is my vertex. From there, I'm just plugging in more numbers. When I plug in negative 4, it's going to kick out, When I plug in negative 4, it's going to kick out negative 1. And when I kick out negative 5, it's going to kick out a positive 3. Ooh, I'm sorry, that's not right. I meant to say 0 here. Apologies for that mix-up. And once I have those numbers, I like to go and plot them. So at negative 4, I have 0. At negative 5, I have positive 3. And if I know anything about predictions, it's that this line of symmetry is going to, axis of symmetry is going to give me a line to follow across to give me my other 2 points. So at negative 2, my value should be 0, and at negative 1, my value should be 3. When I plug those back in, I do see that they in fact work. So once I've got all my points lined up here and I've double checked my table, I'm just going to go ahead and sketch that function. And I know it's not going to be real accurate, but I would like at least those 5 points and then a general idea of what this graph should look like. So now let's jump down and let's connect this to what we've been doing this entire time. So what happens when we switch from a function to an equation? And remember, the only thing that we're doing to switch it to an equation is we're setting it equal to 0 instead of setting it equal to f of x or to y. These two things are interchangeable if you remember from our earlier units. So now that we've changed it to an equation, we can find the solutions. And this is finding those solutions like we did in the last chapter. This one, because there's no number out in front of x, we have to find what multiplies to 8 and adds to positive 6. Well, I know that 4 and 2 multiply to 8 and add to a positive 6, so I'm right away going to jump in and I'm going to say a positive 2 and a positive 4 will give me the answers I need. Now, how do we find the solutions? Because this is just the factored form. This isn't the solutions. We have to use our knowledge of this equaling 0. Remember, when we have something that equals 0, we can use the ZPP, or the zero product property. And that says that either the first term is going to be equal to 0 or the second term is going to be equal to 0. So in order to find the solutions, I have to solve those down. So I get that my two solutions are -4 and -2. Now I want you to look back at the graph that we just created as well as the solutions we just found. What do you notice about the solutions we found and the graph we created? Do you see anything important? Well, if you look at it for a minute, what you should see is that your x's that are your solutions to your equation are also your x-axis intercepts. Notice how I cross the x-axis at -4 and at -2. Those are my solutions on both the graph and the solutions to my equation. So if something crosses the x-axis 2 times, once, twice, it's going to have 2 solutions. So let's take that a step further. Is it possible for a quadratic equation to have 0 solutions, 1 solution, or 2 solution? Well, let's find out. Is it possible? We just saw the 2 solutions one, so we know that one's pretty simple. That one is possible because your 2 solutions exist when you only cross the x-axis 2 times. So there's 2 solutions. If you remember from yesterday, it's also possible to only have 1 solution because we may have something that comes down, touches the x-axis, and then goes right back up. That only has 1 solution. Now, is it also possible to have 0 solutions? And this is the tricky one, and this is the one I've been working backwards towards. So is it possible to have 0 solutions? Well, is it possible that we have a parabola that never ever touches the x-axis? Yeah, absolutely it is. We could have one that sits high up here and never touches the axis, or we could even have one that sits down here that comes really, really close but never quite touches anything. So because there's never anything touching this axis, there are no solutions. All right, let's jump down to these problems. So if we use the related graph of each function, let's determine its solutions. Now we could solve this for x, or we could notice where our x-intercepts are. Notice this point here is the origin. I'm sorry, I believe this point is the origin. Let me double check that. It's always so hard to see the origin, but I believe that the origin is in the top left. Yes, it is. Sorry about that. No, I was right with the origin. So what are my solutions? Well, what are my x's where it crosses? -1 and at +1. So my solution for this problem is -1 and +1. The next one, and I'm going to highlight my axes so we can see them a little bit easier, because I know it's hard on paper as well as on my computer here. So when I highlight my axes, how many times does my parabola cross this line? It doesn't cross at all, correct. So this one is going to have no real solutions. 0 real solutions. Now in Algebra 2, we get to talk about imaginary solutions, but I will save that for later. All right, again, let's highlight my axes here. Where does my parabola cross my x-axis? Well, I notice it crosses at +1 as well as at +2. So my x answers are +1 and +2. That's all there is to finding solutions on a graph. And you can see it's a lot easier here than factoring every single time. So if you have a graph, you're going to want to use this method. All right, let's jump to the backside, see what's going on there. So find the root solutions or x-intercepts of the quadratic equation by factoring. We've already done this. This should be a review for you, but it's good to review. Notice I only have 2 terms here, so this is not one that I can just go right ahead and use my XPulse or anything. When I have two terms, my first method is to see if they have a GCF in common, and I notice that they do. I notice, in fact, that they both have a 2 and an X. So I'm going to pull that out of both. I'm going to undistribute that out of both, and I'm going to put it out in front. Now, when I undistribute it out of the first, I'm left with 3x. When I undistribute it out of the second, I'm left with -1. And it still equals 0. Now, why did I want to rewrite it this way? Well, because now that we have a product and we have something equal to 0, we can use our zero product property that says the first thing equals 0 or the second thing equals 0. And from there we solve. When I solve the first one, I get x equals 0. When I solve the second one, I get 1/3. All right, I want you to pause the video here and see if you can do the next two on your own. These should be a review from the last chapter. So once you're done trying those on your own, please come back and see if you've done them right. All right, hopefully you paused the video and you had a chance to try these on your own. For me, I noticed this one does not have a number out in front, so I can go right to my parentheses. And once I go to my parentheses, all I need to know is what multiplies to +2 and adds to 3. Well, 2 times 1 makes a +2, and if I add 1 and 2, I get 3. So those are my factors. Now I'm going to use my zero product property that says either the first thing or the second thing equals 0, and then I'm going to solve. This is going to be either -1 or -2. All right, last one here. I noticed this one has a number out in front, so it's immediately going to be something harder than the last one, which means I have to use an X puzzle. 4 times -6, -24. My B, +5. What multiplies to -24 but adds to 5? Well, if I list out all of my factors, I'm eventually going to get to 3 and 8. I know one of them has to be negative. Which one is it? Well, I have a +5, which means the smaller number has to be negative. Remember from here, these aren't my factors. I have to rewrite my equation. 4x squared plus 8x minus 3x minus 6 equals 0. And then we factor by grouping. These two have a 4x in common. I'm left with x plus 2. These have a -3 in common. I'm left with an x plus 2. I rewrite this in 2 parentheses to create a product. This should have been a negative. I apologize. And once I have a product, the same way I worked with the other ones, I'm still going to set each side equal to 0. Set this side equal to 0. Set this side equal to 0. When I solve, I'm going to add the 3 over. I'm going to get 4x equals +3, then divide both sides by 4. So I get +3/4. When I use the right side here, I get -2. So there are my solutions. The last idea I want to go over is, what if we're given solutions? What if we're starting here and we are expected to go backwards? Can we do this to generate the equation? So I'm going to show you this first one. Write a quadratic equation with the given roots and then write it in standard form. Remember, standard form is ax squared plus bx plus c. And all that says is that we go in descending order. X squared, x, no x. So normally when we have this, let's use what's up above in order to work backwards. So usually I have an answer at the end of the problem. Right before that, I know that I had to set each side equal to 0. So I had x equals 0 and I had x equals 3. From there, I know that I usually go from parentheses down to a solution. This time I have to go the other way. So to get these into a parenthesis form, I'm going to move that 0 over, and I'm going to say this one is x minus 0, and I'm going to say that this one is x minus 3. I know that's a little bit confusing, but remember, zero product property says one thing times the other has to equal 0. So when I move the 3 to the other side, this time I'm moving it back in order to get it into parenthesis form. Once I get it in parenthesis form, I know it has to equal 0. That's what my zero product property allowed me to do. Now I have a product of parentheses, and this is just simple foiling that we've been doing before. Sorry for that in the background. So x times x is going to be x squared. X times negative 3 is negative 3x. We get negative 0 times x, which is just negative 0x, but I'm going to write it down anyway. And then, of course, negative 0 times negative 3 is just 0. Now I simplify, get rid of all the unnecessaries, and I get x squared minus 3x equals 0. Now that was the long way of doing things, but I do want you to understand where these numbers are coming from. The quick shortcut is what happens between, the first step I showed you and the third step. Notice, our solutions are always the opposite of whatever signs are in our parentheses. So if I want to skip this middle step that's a little bit confusing, I can know that instead of a positive 7 on the inside, all I have to do is put that 7 in there and make it a negative 7. Same thing with my 2. The shortcut version is that I put the 2 in there, but because it's positive in my answer, it's going to be negative in my equation. And then, of course, it's always equal to 0. From there, it's simple foiling again. X squared minus 2x minus 7x plus 14 equals 0. Simplify this down to x squared minus 9x plus 14 equals 0. Just like that. Same thing with the last one, and this is going to be one where we want to use another shortcut. So, in my first set of parentheses, I bring the 1 down, but I make it the opposite of whatever sign it started out as. Second one, I bring the x down, I bring the 1/2 down, I make it the opposite sign of whatever it was before. All right, same thing with foiling. We are going to get x squared, negative 1/2 x, negative 1x, and positive 1/2, because a negative 1 times a negative half is a positive 1/2. Simplify, x squared, negative 3/2 x, because 2 negatives make more negative. 1 plus 1/2 is 3/2, plus 1/2 equals 0. And I have my equations. All right, now that you have seen some examples, go try that homework and let me know if you have any questions.